So this video, again, we're going to be looking at an example where we have to use integration, so definite integrals, to find the area under a curve. This is going to be the hardest example so far. Not that it's that much harder, it's just a little bit different. There's kind of more to it. So if we look at this cubic curve here, so we see that some of the area there is going to be plus and some of the area there is going to be minus. If you think back to the last two videos, when you got the area that was above the x-axis, you got a plus number. When you got the area was below the x-axis, you got a minus number. That's why I have the plus and the minus. So basically, if they ask you to find the area, say between this point here and this point here, and you just integrate it normally, you're going to find an answer that's either 0 or really close to 0, because the plus and the minus will cancel each other out. Okay, so there's another little trick you have to do. So there's two ways. First, they can ask you for the area enclosed, okay, and it'll say enclosed by the curve and the x-axis. So that means basically the kind of closed area there. If you get me, it's closed by those two lines there. There's no kind of space where it can get out. Whereas this here, obviously, the area is just going to go forever. Yeah, that kind of makes sense. Or else they could ask you for just the shaded area. And if they ask you for the shaded area, that means they're going to have a picture and they tell you exactly what they want. Does that make sense? They're the two kind of questions you could ask anyway. So the way you're supposed to do it basically is you're going to get the area from that green one there I'm drawing there to that green one here. So you calculate that area, that you do that in one sum, and then the second time you get this area and this area. So like as in the area from this to this, so it's another integration. So they're two separate integrations and then you add them together. So we're going to see that in an example I'm going to do here now. So I'll just pause the video and draw the example out. Yep, so here's the example here. I just drew it out quickly. So we have our y and our x-axis. We have our green curve here, okay? And we can see that the question is what they want to find is they want to find the total area that's shaded, okay? So the area below, that's between 0 and 2, so this section here, and then the area between the curve and the x-axis, that's, again, this time it's above the x-axis, so this one here that I'm circling with the pen. Does that make sense? So they can ask for something like that, or they could just ask for the enclosed region between 0 and 3. And that means if they ask for it just between 0 and 3, you'd have to break it up yourself first. So here they're kind of showing us how to break it up. Anyway, I'm going to start and just go ahead. So I'll do it in bright blue. Okay, so the area is going to be equal to A1 plus A2, I'll say. Okay, where A1 is going to be equal to the integration from 0 to 2 of x squared minus x minus 2 dx, okay, and then A2 is going to be equal to the integration from 2 to 3 of, again, x squared minus x minus 2 dx. And there's one little point I'll make about A1. It's going to say positive, okay, and what that means is that we're going to take the positive value, because remember, because A1 is this one here, it's below the x-axis, it's going to be a minus number. We're just going to take the positive of it, so we're just going to change the minus into a plus at the end. So anyway, I'll just go ahead and I'll calculate A1 and A2. So A1 is going to be equal to, it's going to be x cubed over 3 minus x squared over 2 minus 2x from 0 to 2, and that's going to be, so it's going to be 2 cubed over 3 minus 2 squared over 2 minus 2 multiplied by 2 minus, and in this one it's just going to be 0. So if you see 0 there, and if it's just x squared, x, they're all going to go to 0, so you don't have to calculate that. So this here then is just going to be minus 10 over 3. Okay, so that's area 1, and again we're going to take the positive of that, so we'll come back to that later. Then A2, right down here, actually do A2 in a different colour just to mix things up. We'll pick orange, don't do orange that much. A2 then is equal to, so again it's still going to be the same integration, because it's the same curve. So it's x cubed over 3, I'm just copying this one from above. But it's just the limits of integration are going to be different now. Now it's going to be from 2 to 3. So if I can squeeze this in. So I'm going to try, this is going to be 3 cubed over 3 minus 3 squared over 2 minus 2 multiplied by 3, big bracket, minus 2 cubed over 3 minus 2 squared over 2 minus 2 multiplied by 2, close the bracket. Okay, sorry, it's getting a little bit messy. That's going to be equal to minus 3 over 2, this one here, minus, this one's going to be minus 10 over 3. Okay, so our overall answer then is going to be plus 11 over 6. Okay, because minus minus will make it plus. Okay, so that means our total area, I'll finish this off in red, area is going to be A1, I'm just going to say, no, I'll put a plus in front of it instead. Okay, plus A2. That's just to remind us to have to take the positive, it's not minus 10 over 3, okay? So that's going to be equal to 10 over 3, so remember plus 10 over 3, plus 11 over 6, and the final area is equal to 31 over 6 units squared. Okay? So hopefully the basic idea that makes sense. So they can be harder, they can be easier, but it's just as long as you understand that you have to break this up into 2 sections and then try and integrate each section individually, then you'll be fine. That's the main idea that I wanted to get across in this video. There are hard examples and easier examples, so you have to just kind of work through them, see the harder examples, try and understand them. But once you understand the basic concept, that's the most important thing anyway. So if you want to get the area and it's some bit is below, some bit's above, you have to break it up into 2 separate bits or else they'll cancel out. Okay, hopefully that made sense, and then we're going to look at the area between 2 curves later. Okay, so in the next video it's going to be area between 2 curves. See you then.